All right, welcome back, students. We are doing 3.4, and today we are doing graphing parabolas with vertex form, or maybe it's in vertex form, with vertex form, in vertex form, whatever. So, vertex form. What is vertex form? Well, vertex form is a form of writing a function that will allow you to pick out the vertex straight away. And this is what it looks like. It looks like the function f of x equals a times x minus h squared plus k. Okay. Now that's important to write that down because this is kind of fundamental to what we're going to be doing today. This is your base, so you can refer back to this. Maybe put a big star in the corner of the page or something. But this is one of those pages that we're going to refer back to. And so let's define each one of these. So first, the A. The A determines happy which is a positive parabola, or sad, which is a negative parabola. It also does stretch, shrink, makes it get fatter, makes it get skinnier. So your A value does all that. It determines if it's an upward facing parabola, a downward facing parabola. It determines the stretch or the shrink. Now the H is H equals X value of vertex. And the K equals the Y value of vertex. So you have the X value and the Y value. So what do I mean by that? Well, let's look at one. Here's an example. Y equals, so that's what you need to know. Y equals 2 times x plus 4 squared plus 5. So based on this, what's my vertex? My vertex is what? It's an x and a y value. It's your h and your k value. Okay, you ready? Did you get it? You know what it is? Negative 4, 5. What? That's a positive 4. Correct. But it's the opposite of this because our original equation is minus h. So if it's minus a negative 4, that makes it a positive 4. So a negative makes it the opposite of whatever value it is. This positive means it's just that value. So when you're doing your x value, make sure it's always the opposite of what that number is. So our vertex for this one right here is going to be negative 4, 5. That's our vertex. And our axis of symmetry? What's our axis of symmetry? It's negative 4, right? Because our axis of symmetry is the x value of this. So if I were to look at this one, my vertex is negative 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So there's my vertex. It's going to be a happy face. This is positive, so it's going to go up. And it's going to have a vertical stretch because that's larger than 1. So it's vertical stretch. So it's going to be something like 1. It's going to be something like this. Give or take. It's going to be something like that. And I know that just because I got my axis of symmetry and I got my vertex. I do have my axis of symmetry. And I have my vertex. Okay, let's try one more just to know what we're dealing with. What if I had, oh, and then how does this compare to, how does it compare to this? Let's do 3, 9 also. So how does this compare to y equals x squared? Well, it shifts left 4, shifts up 5, and it's a vertical stretch. That's how it compares. From our original, it shifts left 4. From our original, it shifts up 5. And then it's a stretch. It comes in. So if you're comparing to the parent function, that would be what it compares. What if you had y equals 1/2 x minus 3 squared plus 2? What would your vertex be? And your axis of symmetry. Okay, so your vertex would be the opposite of that, so 3, 2. Don't forget, it's the opposite of this one. So it'd be 3, 2. Your axis of symmetry is 3. All right, are we good there? Okay, I hope you're watching this because you do not need to do 1 through 4. We're going to move on over. And 1 through 4 you can skip. I am now on page 92. And starting on number 5, find the vertex and the axis of symmetry of this function. So let's see, there is no k value. My y value is 2, so my vertex is 2, 0. And my axis of symmetry is x equals 2. Go ahead and find the vertex and the axis of symmetry for that. Number 2. Number 3, I'm sorry, for number 6. Number 7, I'm going to go ahead and let you find, well, I'll help you with this one. So the vertex for this one is going to be 1, 4, opposite, same. The axis of symmetry is going to be 1, or x equals 1. All right. Compare this graph to the graph f of x equals x squared. So what I'm going to do is I'm going to do f of x equals x squared with pen. We know what f of x equals x squared looks like. Looks like 1, 1, 2, 4, and then 3, 9. 5, 6, 7, 8, 9. So this is f of x equals x squared. Okay, now let's check this one. F of x equals 3 times x plus 2. So our vertex is going to be negative 2, 0. There's our vertex. It's actually going to go up 3. So, two, so that's 4 times 3, that's 12. So it's going to be 12 is up here. So we have shift left. We shift left by 2. and it's a stretch because that's greater than 2. It's a stretch. So compare, my comparison, shifts left 2, and it's a vertical stretch. All right, give that a try for this one. And then for 11 and 12, we're going to do the same thing. We're not going to compare them. We're just going to graph this one and compare it to our original. F of x equals x squared. So I'm putting my x down here at the bottom, my x-axis, because this is positive. That one's negative, so I'm going to put this for this one with my x-axis because I'm still comparing it to my original. But it's going to be a downward happy face. Oops, the vertex is up here, but whatever. So this one's going to be downward, but I'm still going to compare it to my original one. So there's my original, like that. This one, here's my original, f of x equals x squared. So I'm comparing it to this. So I have my vertex. For this one, my vertex is -1, -1. So -1, -1. There's my vertex. And then again, it's going to be a vertical stretch. So it's going to go something like this. And then how do I compare it? It shifts left 1, shifts down 1, and it's a vertical stretch. All right. All you have to do is a couple more problems and describe the shifts using vertex form and understanding that when it's written like this, that is vertex form. All right. Have fun with that. Please give me a call or ask any questions that you have. Have a wonderful day.